Hello, everyone, and welcome back. Today is the second day of the free week for our software quality assurance testing lessons. Please confirm if you guys can hear me. Hello, yes, thank you for confirming. All right, so yesterday we talked about testing in general and also software testing. And today we're going to move on to a very important topic, which is defect. And another word for defect is bugs, and also defect lifecycle. All right, so let's move on. Let's quickly look into the 5 days agenda again. This is a day 2. Tomorrow, you will be introduced to the SQL or SQL. And the day 4 will be dedicated for Python, and day 5 for basics of test automation. Let's move on. So before we jump into the defects or defect lifecycle, let's just look into a bigger picture of how applications are actually developed or delivered to the clients, right? So there are 2 widely used methodologies in the industry. One of them is called Waterfall, and the other one is called as Agile. So I'll just try to explain it in a very simple way. So if you look at this picture here, think of it that way. If you deliver the product in one piece after a long period of time, that's Waterfall methodology. If you deliver it piece by piece over a period of time to the end client, that's an Agile, right? So, and there's special, terminology that's used when we talk about piece by piece, that's incrementally and iteratively. So, and there, depending on what kind of application that the team is developing, one or the other approach is a better fit. There's no such theory or widely accepted understanding as Agile is always better than Waterfall, or Waterfall is better than Agile. There's some obvious benefits of the Agile, though. So we'll look into that in the next slide. Let me just. So if you look into this slide, the difference, as I mentioned, between the Waterfall and Agile is that Waterfall takes some time to deliver the product to the end client, and that sometime can be actually very lengthy and extended. And as technology changes, and also the needs and requirements of the customers also change over time. So they might have requested certain list of requirements, 6 months ago, but after 6 months or during that 6 months, the requirements might have changed. So if we talk about, let's say, financial institutions, their work or their applications, their software is regulated by the government, by the Federal Reserve and the certain departments of the Federal Reserve, who impose new laws and new regulations all the time, continuously. And that means the requirements also change over time, right? So the requirement that is actual currently now is not the same after 6 months or 1 year. So if you look at this picture on the left-hand side, so there's this green area, and then there's yellow and red area, right? So this green area is the area where client will be happy. So that's client's expectation zone, basically. So when you're working in an Agile methodology, you actually deliver the software incrementally, usually in 2 weeks periods. And there's a special term for this, sprints, right? So what happens during this 2-week sprint is that development team, together with the testing team, they actually select certain number of requirements or user stories, as we call them, and then say where we will be able to deliver those requirements, those features during that 2 weeks period, or it can be 3 weeks or 4 weeks. And then they deliver that. And then they what they do is they showcase, they also, meet with the end client, or it could be just within the same organization, meet with that department that actually needs that application, and then show them what you have already delivered, right? And then get feedback. So, and getting a feedback is always, that's a great thing, right? So that keeps you on track and then on the right direction. So that, as you can see here, during each sprint 1 and 2 and 3, you are sort of, on the track, going, sort of deviating sometimes from the correct direction, but at the end, over a period of time, you're still hitting that point, which is within that green area, right? And if you compare it to the waterfall, though, you almost basically don't meet with the end users over a period of time. The application is developed, actually it's designed, and then all those requirement documents prepared, and then the developer works on it, and then testing team, and then it just gets to the users. Also, not to all of the users, but a small team within the users that's called like user acceptance testers, and they may not be very much happy with what they're seeing. So that's just the overall picture for you, so that you get that idea as well, so that you know the difference between Agile and Waterfall. But we'll talk in detail certainly about that in the actual courses. So now let's look into the bug, and then how bug actually comes into existence, right? So normally, software developer makes a mistake when they're coding, because defects are in the code, and they make some mistake. Maybe instead of putting greater than sign, they put a less than sign, or greater than equal. They just put just a greater sign instead of that. So we all are human beings, and they make mistakes too. They get tired, they fell asleep, and whatever happened, they made some mistake or error in the code, and that leads to a defect, right? That leads to a new bug. Bug and defect, you can use it interchangeably in the application. And then users, or you as a tester, you put yourself in user shoes whenever you're testing, right? So, and then you will see the failure, right? So I know those are like 3 different terms, very much related to each other: error, bug, and then a failure. It is in fact one of the questions in the ISTQB exam as well. It's very highly unlikely you might be asked a question like that in the interview, though. Asking you a difference between error, bug, and failure, but just for you to understand the overall picture, and then how it actually happens. And so you're going to see the failure, and failure would be in the form of an unexpected error, or maybe an incorrect value, or incorrect data in an incorrect format. And we're going to see some of the examples of defects as well. So here's one fun fact before we move on. That's the world's first computer bug, and it was not an ordinary software bug, but it was an actual moth that was found in the computer hardware, and it was actually causing a malfunctioning in the in the software overall, in the functionality of the software, because there was a problem with the hardware. So And what you're seeing here is you're seeing a picture, but that's you can call it as an evidence, right? So as a software tester, you will be, whenever you find a defect, you will be taking an evidence. You will be taking a screenshot. So that snipping tool will be your friend all the time, basically. And this, if you look at this, this is like an actual evidence that is taken from a first computer bug, basically. All right. So let's look into some of the examples of bugs, right? So, in order to find the bugs, you need to see some examples, like, oh, what kind of examples, that might be. So here's one simple message that you might have seen in the past: 404 error message. Whenever you go to a certain website, looks like this page doesn't exist, or and this is a common error actually that shows up whenever you're testing web-based applications. So here's another one: unexpected error occurred, and try again. But this is related certainly to a desktop-based application, as you can see from the format of the pop-up message. Here's another one, right? So unexpected error occurred, and another one, and asking you to refresh. So this is a common type of bug that you might actually see whenever you are testing software. So this can be categorized as error messages. And most of the time, those error messages, this type of unexpected errors, are categorized as a showstopper defect. It may or it may not be. Let's just imagine you were just given a new application to test, a new version of the application, or as we call that, as a build. New build of the application was given to you, either was deployed. Deploy basically means installation, right? It was deployed, it was installed in your test environment, in your QA environment. You either do it yourself, or the deployment happens is done by the developer. And the first thing that you do is you do smoke testing, right? So I just gave you this another term, smoke testing. So what is smoke testing? Smoke testing is basically just going through the application for the first time, making sure that application is up and running, right? The application is up and running. You can view the application, and also the major modules or components of the application are testable, right? They are accessible, basically. So it happens right after the deployment, right after the installation. Whenever they say, developer says, hey, QA, application is ready to test, go. So you get that email message and you're ready to go, and then you go to this test environment, type in this URL, web address to the web application, and you get this error message, 404. Unexpected, this page doesn't exist, or something like that. Or maybe not at that point, but a little later, you'll log in to the platform or to the application, and then you start just checking if you can actually access some of the important components of the application. You get that message, right? Unexpected error occurred, something in the database, something in the servers, something. It just kicks you out of the application. This is called as a showstopper application. Showstopper defect. We'll talk about that defect severity levels a little later, and it will actually stop you from proceeding. Right, that's why it's called as a showstopper. So let's look into another type of defects, another category of defects that are called as permission issues. Now, think of any application where you probably remember if there were any roles that are attached to the users. So it is mostly, if it is a banking application, then certainly there's going to be someone who creates a record and another role that will be actually approving the record. It can be an accounting application or tax application. There's always several layers or several different roles of users who have different permissions, right? You might have, when you log in with a role of a viewer, you can only view stuff, and you won't be able to edit or create new records. But if you log in with a role that is more of an editor, now you can create stuff. You can create a new customer. You can add a customer. Maybe you can update a customer. Now, think of those, bank employees, right? So whenever you go and then you open an account, there is someone who's sitting there and then creating a new customer, adding your records into the system. And that doesn't usually happen automatically. That just goes to another layer, maybe to another department, maybe their manager, who just gets this pop-up message saying, hey, new customer was added. Do you want to verify, review, and then click approve button, right? That approve is enabled or visible only to that level of employees who has this role, who has this particular role that says approver, right? And it's also called as a 4-eye control. What does it mean? 4-eye control, right? So one person, you have 2 eyes, but it's usually important and crucial to have another pair of eyes to look at the record or the or the process, making sure that everything is okay, right? So therefore, there's security roles and permissions level restrictions for access is implemented in the applications, and you're gonna certainly see that whenever you will be actually exposed to testing applications. In those kind of applications, common mistakes that developers make is giving the wrong permission. This is when you're going to get like you have a user and you know that user has approved permission and you're trying to approve and you're like, you're not allowed to approve. Or you want to submit a record, you want to submit the new customer for approval, but your submit button is disabled, right? So instead of being enabled, it's disabled. It's just like just like the mistake that developers make. Instead of putting greater than sign, they put less than sign, or they forgot this equal sign after the greater sign. So roles and permissions related defects, basically, right? This is frequently encountered in the applications, and here 2 examples. User with viewer role should not be able to submit, but application is allowing. Now, this can be actually a defect title here, right? You can take that and then create a defect. Or the other way around, user with editor role should be able to submit, but application is not allowing to submit. So you have a permission based on the requirements, and that requirement is, by the way, called as a security matrix. Security matrix. Security matrix means it's a piece of document, usually comes as part of the functional requirement document or separately as an independent document that provides information about which role has which functionality, access to which component of the application, and so on. So based on that document, editor role should be able to submit, but the application is not allowing, right? So that's a defect. So, right. We reviewed the permission issues. Let's move on. Now, this one is more of a format related. So you're gonna be probably finding those defects a lot as well, and also tiny defects with low severity that sometimes doesn't have much impact, but it really depends though, right? If you if you're in a trading application, let's say, if you ever use the trading application, like a Coinbase, or you're going to see that after the dot, the decimal points, they're like 4 decimal points, right? Because the trading happens and then in those decimal points mostly. And if the application doesn't display or incorrectly displays those 4 decimal points, then that certainly that might be a huge impact. So let's see the first line here. That would be 1,000 separator, and I personally see that issue a lot, and that gets reported and developers fix it. Usually developers they just leave it to the end. They're like, oh, I know I have to do it, but I'll take care of the more important stuff, and then they forget, and then they say I'm done, and then they deliver it to the QA, and then the QA starts testing, and then that's when you're going to notice those kind of expectation, the difference between the expected conditions and actual implementation. So as you can see, 1,000 separator is important, because just looking at the actual implementation on the right hand side, you won't be able to tell whether it's 1 billion or million or 10 billion. You're right. So especially for the users, like accounting department, that would be crazy. They would just go like, no, please fix it. So the next line, let's look at the one that's 5.1262. Right, this is the expected condition. So similar to the trading application that I just talked about. And on the actual implementation on the right-hand side, as you can see, it is 5.12. So what is happening here is, in testing term, is called trimming, or we also call it as a truncation. But truncation also related. There's has something to do with a SQL. We'll talk about it tomorrow. But that terminology is used here as well. So trimming, right? What's happening is that they didn't put the correct format when they were, coding, and the result is that instead of getting 4 decimal points, we're getting 2 decimal points, and that's a defect, and you got to report that. So rounding, that's another frequently seen defect. Rounding. So instead of, you expected condition is that should not be rounded, or it should be rounded to 2 decimal points, but they're actually rounding it to 1 decimal point, or the rounding was never requested, but still, they're rounding it. As you can see, 0.16 is rounded to 0.2. Sort of mathematically correct, but not expected, right? It's not what that expected condition is. Now, date format. So date format is another issue that you're going to see a lot. Here, as you can see, the date format is 0115, but then they're just putting 1 instead of 01. Now, it may or it may not matter. Customers might accept that as well, but one important thing that you have to take into account, that applications do not work in isolation, especially in large organizations. Applications are always integrated with other applications. Applications, get data from one application and then actually also provide data to another application at the same time. So if your format is not correct, then that integration might actually fail. Right? So sometimes, right? So that's, and therefore it's important to pay attention to little things as well. Now, timestamp format. Timestamp format is when, so whenever we say timestamp or date time instead of just date, we mean a date and then a time, right? So if that format was expected in the requirement document or in a technical design document, but the actual implementation was just the date, then again, that's a difference that you should be looking into and you should be reporting. All right. So here's a question. Could you explain again about smoke testing? And is that when you have to test the main functionality? So smoke testing is the first thing that you do when you start testing the application. It's also called as a build acceptance testing, right? Now, think about it, build acceptance. So this is when you are making a decision to accept the build or to reject it, just like, developers reject your bug. So you can, again, it's checking the application is up and running. First quick test, smoke test would be, if it's a web-based application, just go to a website, the URL, and then see that it's working. And this expected page comes up. It comes up, your first step or first test case of the smoke testing passed. Now, if it's a login-based platform, login, and then, when you log in, usually any application has components. Like if it's a e-commerce, then there's products, a shopping cart, and orders, and whatever, my account, profile. Just click on them, each of them, and just navigate through. You don't get any, unexpected ugly message. You're good to go. So this is what the smoke testing is about. So you don't test the actual detailed functionalities, because that's your functional testing. That's your system testing. But you just make sure that the application is ready for testing. If it's not ready, then you have to report back immediately, because if you don't report back immediately, then that's going to impact the timeline, project timeline. So that's the purpose of the smoke testing. All right, let's move on. So now that we kind of saw some of the defects, right? The samples of the defects, and let's just give a definition. I actually gave some quick introduction to defects yesterday as well. So we're going to repeat that here. So bug or defect is an unexpected behavior in computer software. As simple as that. Unexpected behavior, right? So here's more detailed explanation. So bug is the difference between the expected conditions and actual results. So it's a difference, it's a deviation between your expectations as a tester or as a user and what was delivered to you, when whatever you're seeing on the screen or the behavior of the application that you are observing. Other, terminology that are used interchangeably here, you can say defect or, fault or glitch or whatever. So let's move on. Okay. So here's one frequently asked interview question. Why is it important to find the defects early? Now, when there's one terminology here that's used, SDLC, that means software development lifecycle. So that software development lifecycle is how the software becomes a software from a requirement, from an idea into a final product, right? And as I gave you that little introduction at the beginning, there are two different approaches to manage that whole software development lifecycle. One of them was Waterfall, and the other one was Agile. And the question here is that, okay, why, it is important to find the defects earlier in that process? Why, right? So the answer is that the later you find that defect, the cost of fixing that defect is gonna just multiply, right? So you find that earlier, whenever they're defining the requirements, you can actually find the potential defects. Actually, it's called prevention, right? You can prevent that defect already when the documents are being designed, when the user stories are being created, right? User stories is the same thing as a requirement. Think of it that way. It's just, I showed you the functional requirement document yesterday, but it's just another way of actually documenting the requirements of how the application is supposed to function at the end, right? So, and the if you can prevent the defects at the beginning, whenever those requirements are being defined, or at least, you know, if you find a defect at that point, as this is a, you know, statistics, I think we took it from IBM, $100, that's a cost of the defect if you just find it earlier. But then if you find it later in testing period, so when we say testing period, that is, we're talking about, it can be unit testing, that's what developers conduct. It can be the QA testing that we testers, you know, do, and also another level of testing that user acceptance testers do. That is a group of, you know, users, basically, before general, you know, whole group of users get access to the application. Group of little, you know, small group of users, actually subject matter experts in that application. They just go into the application and test and make sure, and then accept. That's why they're called the user acceptance testers. So if you still find that defect during those 3 different testing periods, it's $1,500. That's, you know, on average. So where's that money, you know, that amount coming from? That's probably, you know, coming from the money that's paid, like as a salary, as a payment to the consultants for the testers. You can think of it that way. But if you find it in production, right? What is production? Now, who can tell me what is production? What do I mean when I say, if you find it in the production? If you find it, any answers, any ideas? With real, exactly. Yes. Deployment. Right. Yes. Correct answers. Delivered product. Yes. There's another term here, or the phrase that we use when the application goes live, right? That's the production. There's non-production environment and there's production environment, right? It's when we say environment, where in fact we're simply talking about computers, actually, or servers. Server is a computer. So when the defect is found, as you guys mentioned, with the real users, with the general, you know, public, whenever you get a new version of the Instagram or Telegram, and then you found some defect, that's when the defect is found in production. And the cost there is a lot higher. As you can see, it's 10,000. It could be a lot more. This is just a, you know, average number. There are cases when, especially in banking applications, I mentioned that, you know, government regulates banking applications, especially against anti-money laundering, right? Money laundering is crime, and they make sure that it is regulated and it's controlled by the banks, or fighting against sanctioned countries or sanctioned individuals and organizations, right? So if the certain organization is sanctioned, and banks should have a software that actually catches and prevents transactions with that sanctioned, restricted individual organization. And if they don't do that, or if they, you know, if they have some bug in the system that accidentally or intentionally, whatever, they skip that, they, you know, they make that transaction. Now it's not 10,000. That is millions. You know, you can read it on the, and it's always there. You know, I think, you know, many big banks that you already know went through this in the regulator department of the U.S. government. It's called the FinCEN. It's part of the U.S. Treasury Department. They impose millions of dollars, and therefore, you know, the companies are so cautious about making sure that their applications are actually bug-free. So, you know, there's a huge demand and growing demand for testers. All right, so let's move on. Now, bug lifecycle. What is a bug lifecycle? So bug lifecycle, just like a software development lifecycle or software testing lifecycle, is how the bug comes into existence and how it goes through all this back and forth between testers and developers, and then how it gets closed at the end. All right, so let's review the cycle. So first step, you found a bug, right? Congratulations. So you found your first bug and you're happy. And at that moment, of course, it's not a good thing to find a bug overall for the project, but it's, if you think of from another angle, you just save this thousands of dollars of potential cost for the company. So testers, it's our job to find a defect. So we found a defect, you found a bug, and at that moment, the status of the bug is new. Normally, right? It differs from team to team and depending on which application that you're using, but this is a general workflow so that you get the idea. It's new. Now, what happens to that defect? It's in the system. It can be in the Jira or in the Azure DevOps that I showed you the other day, or it can be in another widely used application called Quality Center or Application Lifecycle Management, ALM. So in that system, somebody gets a notification email and say, hey, new bug was created and it was assigned to you. And it's assigned to a lead developer, sometimes in certain organizations to a business analyst because they know the application better, right? And then that lead developer analyzes the bug, reads through your bug report, and then decides, is it a valid defect? Is it a valid defect? So if it's not a valid defect, right? Sometimes it's not a valid defect. Maybe you were wrong when your tester's understanding of the requirement was wrong, and they're sure that this is right. This is how the application is supposed to work. They just reject it, right? And there's a whole different conversation that goes on whenever it's rejected. So, but if it is valid defect, then another question to be asked here is it in scope? So what does that mean? Is it in scope? That means the scoping, it is some sort of issue, but we're not fixing it now. It's certainly not within the request of the users. Users requested something, but then you found some additional issue that might be needed maybe in the future, right? Or if you think of the Agile type of implementation, as I explained, you pick certain requirements, like 5 requirements maybe for the period of 2 weeks, and then you try to deliver that together with the development team. And then there's a defect they just got opened, but it's not within the scope of this 5 user stories that you're trying to deliver. So then it's, sorry, it's not in scope. That's not what we're trying to deliver. So let's just defer it. Defer it means that we're going to do it sometime later. Okay. So if it is in scope, then another question is it already raised? So that happens because in one team, sometimes like 2-3 testers working at the same time, right? Even more. Sometimes if it's complicated application, 3 testers working at the same time, and then they just one create defect, another create defect that is very similar in nature, or maybe identical. And if it is identical, if some developer are already working on it, it's a duplicate, right? So they don't want to waste time, working on duplicate items. If it's not the same item, if it's not a duplicate, then it just gets assigned to an actual developer. So they know who is working and who is available based on the resource availability. They assign it to a certain developer. The developer starts fixing, and at that moment, it's in progress. The status is in progress, right? Now, what's next? The next step is the good news that developer fixed your defect and gave you a new build. So developer fixed the code. They did root cause analysis. They found what the issue was. And then they gave you the new build. Build is a version, don't forget. So it's just a new version. So whenever you get your iPhone gets a new update, like I haven't, and you get a notification or you want to download the new version of the operating system, that's a new build, sort of. It's actually a release at that moment. But that's the idea, right? So you get the new build, it gets deployed into the queue in your test environment. At that moment, the status of test, the defect is fixed. It's fixed. Now you come into the picture, right? So you retest the bug. You retest. You basically rerun your test case. Whatever test case that you were running that failed, you just rerun it. You just go through the same steps, make sure, that defect is gone, it's fixed. And you make a decision here, right? So test passed. So if yes, then yes, right? So you actually did the great job. So you communicated the bug, and that's the happy conclusion to this story of the bug, basically. So, but if it's not, right? If your test case again failed, then the status will be reopened. That happens from time to time, mostly due to communication issues between the developers and testers, and it could be also environment issues or deployment issues as well. So there are many different potential root causes that might be why the defect gets reopened. So all right, so here's an example of a defect from Azure DevOps test management tool that we used yesterday. So as you can see here, you're going to create a bug, and then first thing that you do is you give a title to the bug. You give a name, just like we gave a name to a test case yesterday. It has to be concise and meaningful, and making sure the whole idea of creating a bug report is getting that defect or the bug fixed and closed, right? So you have to put an effort to make that as descriptive and as clear as possible. Some QA testers, they just put too much stuff maybe in the title sometimes, the whole description to the title. So for that you have a description field at the bottom. So, or some testers, they put a little bit of maybe a confusing title that developers will not be sure. They won't be sure, like what is the issue here, and then they're gonna reject the defect or call you or ask you to organize as video call like this and then explain and walk them through. So your defect should be very, very clear, defect title especially, and the content too, right? As for the content, what do you include inside the defect description? Steps to reproduce. That's a very, very important part. Steps to reproduce. That's probably the most important piece of information that goes into your defect description. This is your steps, your actions that you took to actually to get to that defect, so that developers can also take those steps and then see, oh, okay, I'm getting that defect as well, let me fix it, right? So if your refrigerator got broken or something and you call the service, they're just going to ask you, like, what happened, what were you doing, right? Or your car broke down and stopped working. If you call, they're just going to ask you for the steps, right? They're going to ask you for the steps, and then you're gonna go ahead and explain. So just like that, right? You need to help the developer to fix it. Here's an example from Jira, right? Same thing. You put the so as part of our courses, we certainly give access to the Jira and Azure DevOps, and you will be actually practicing and gaining experience, creating defects, creating test cases, executing them, and so on. So here, again, you can see the steps to reproduce, and also there's another piece of important information here, which is assignee. So who are you assigning this defect to, right? That's an important piece of information. You have to, and usually you go around and ask your QA lead, oh, who's the developer for this project, and who should I assign it to, or should I assign to the lead developer, and so on. So whenever you assign, that person becomes the owner of that issue at the moment, and then that person gets a notification like, oh, that's my stuff, I have to work on it, and they have this deadline, milestone, and so on. So here's another example from a test management tool called Quality Center, HP Quality Center. Currently it's ALM, and same thing, same type of information. It has a lot of fields here. Remember, those tools are configurable, right? When you join the team, you might see, a lot more than what you're seeing here, or fewer fields and some customized fields, because those tools are customizable. So you can basically change or add new fields and so on. Another important field here that we need to talk about is the severity. And I'll talk about it separately. User information. So which test user you were actually using when you were testing this application. That's important part of a piece of information as well, right? Which role? Remember, we talked about roles, security matrix, right? So you have to mention which role of a test user you were using. What was the username? What was your password that you were using? Maybe developers want to go into your system and then check. So all right, so let me just answer some of the questions here. All right, so release product while it's out. Yes. Okay. How many times one application is tested? Okay, so how many times? So okay, so initially, right, so before you even start testing, there's a test planning phase. In test planning phase, you're going to plan, or your QA lead actually plans, what types of testing will be conducted for this application, and in which cycles. Usually it goes through like a smoke testing, and then goes functional testing. And during functional testing, you're interacting with the application, and if you're not doing any other testing, like in automation testing or backend testing, and you find the defects, and then you go through this defect life cycle, which is you report, you retest, open a defect, you retest, until all the defects are cleared. When all the defects are cleared, usually you perform a regression testing. After the regression testing is done, you're done, basically. All right, so regression testing, though, and that's where the automation comes into picture, and we'll talk about that, right? So here's another frequently asked question. What if developer rejects your defect? It is asked a lot frequently during interviews. And here's the answer, basically. It is, first thing is you have to understand the reason why the developer is actually rejecting, right? So it's important to understand, you shouldn't jump into an answer right away saying, oh, I'm just gonna, reopen. No, you shouldn't just reopen. You have to first understand the reason. Usually in any test management tool, there's a comment section, and in the comment section, they're going to put a comment saying, we rejected this because look at this particular document. You were reading the wrong document. You were reading outdated document. Maybe here's a new version of the document, or that you should look into. That's why we rejected the defect, or this is the way it's that we understand the requirement and your understanding is wrong. So so you kind of have to understand. Or they might say like, oh, you know what, we tried so hard and we couldn't reproduce at all. We used your steps to reproduce. We can't see it. And we're doing the same actions, but we're not getting that error message, and it's working perfectly. So in that case, you need to make sure that you can reproduce it again. So try to reproduce it again in your own environment, and make sure you get the screenshots. So you need to try to recreate, and you need to make sure you have the same versions of the application, make sure you're testing in the correct environment, you're using the correct browser version. There's, so many elements there when it comes to the environment, right? So, okay. Then if in fact if the developer is right, then yes, it stays as rejected. But if you disagree, if you still disagree, if you still can actually reproduce the defect, then you're going to have to organize a call and explain your thoughts, walk them through, involve your QA lead so that they can also see you have their second opinion here as well, and that's how it actually works. All right, so okay. All right, call him. Yeah, it's a good suggestion, but you always want to be in good relationship with the developers. That, as I said, the communication skills are key in testing. And yeah, developers are your friends. There's always this tension from time to time, but believe me, in better relationship you're with them, your life is so much easier as a tester. And you need to earn respect as a good tester as well, right? So if your bug reports are definitive, it actually, if your bug reports help them to fix the defects, to understand the defects, they're actually gonna respect you more, because they're gonna say, okay, you know what, John's defects reports are always so informative. I find the root cause right away, and I fix it right away. I don't spend too much time with the back and forth. Or if there's another person and then, who provides, poor defect reports, and that takes time and that impacts everybody's work and leads to that tension, basically. So it's just a reflection that, reflection to your work and the quality of your work, basically. So the difference between the severity and priority, you get that question a lot as well in the interview questions. What's the difference between severity and priority? How do you decide severity and priority? And what kind of levels of severity and priority do you know, right? Those are the frequently asked interview questions. So severity, remember, it is the impact of the defect on the software overall, or the particular component of software. Priority is timing. It's the order in which the defect should be fixed and delivered to the end users. So that's the difference. Severity is about the impact. Priority is about timing or order, right? In which order we want to fix. I mean, you might have like 100 defects, God forbid, but then you won't be able to fix and deliver everything. Development team, they have limited resources, right? And then they have to prioritize, right? And therefore they have to go like, okay, you know what, we're going to fix this and we're going to fix that. And of course, that priority comes from the users, actually, depending on the user's needs, right? What they need, which piece of the application or component they need immediately, right? So who decides? Severity is usually decided by the QA team, right? And priority is decided by the users, or it can be together with the users and product owner or the project manager or Scrum Master. So yeah. And the levels are usually it's urgent, high, medium, or low. So again, it is configurable. It is configurable. So let's look at the severity levels, because you might be asked those questions as well, like what's the difference between urgent and a high, for example. What's the difference between a medium and a low? So can you give me an example of a defect that is a showstopper and that is a medium, or that kind of question, so that just to check that you have you've worked with different types of defects and you know the difference, right? Because you will be making that decision whenever you're creating a defect. You have this drop down where you have to select the severity level. So urgent or showstopper defect those are usually found during smoke testing, usually, and it makes certain features or components of the application inaccessible or blocked for testing. And it's a showstopper because it's basically making that component inaccessible. You cannot proceed, right? You cannot proceed, and potentially the QA phase will be delayed. And if QA phase is delayed, it's a knock-on effect. Whole project will be delayed, basically. So therefore, it is and here's an example: unexpected error message when the user tries to log in, and that's a example of a showstopper type of defect. So let's go one level below. That's high, right? If it's high, then we're talking about, all right, so it doesn't stop me, but it's still a core functionality or a business logic that's working incorrectly, right? That might actually be very risky and make the application not usable. So the core application, or maybe there's a calculation logic there, and that logic to calculate your credit score is just messed up. It's not working. It is calculating, but it's calculating something wrong, right? So that is high. So now if we go one level below, then medium, right? So medium is, whenever you hear the word medium or the term, think about a workaround, right? So minor issue with a workaround. Workaround means you can get to that same, from A to B, but then you will have to visit the C as well along the way. So you just have to make this, some extra inconvenient step, maybe go back and forth, click that, back button on the browser, maybe, refresh one time with double click or something like that, so that you get to that point. It's inconvenient, it takes time, but it still gives you the same result. So as you can see here, right, so items in cart disappear if user clicks back button in the browser, right? So if you click back button in the browser, it disappears. And you probably have seen, if you use some applications that says, do not click the back button. We can't handle it, that we didn't take that into account, something like that. So those are the, sort of issues with the workaround, sort of. And the low severity level issues are the cosmetic, usability, or format type of issues. And we actually saw those kind of issues earlier, where the format doesn't match, right? Instead of the date timestamp, they're providing just the date, and so on, or the alignment, and you're looking in and it's like, the whole thing is just organized a little ugly way, and then you can report that as well as a cosmetic low severity level issue, which may or may not get fixed, right? So, all right, so here's another important concept, and that gets asked as an interview question as well: the difference between the bug leakage and then bug release, right? So what's a leakage and release? So the difference is that bug releases when you deliver the software to the users, knowing that there are some issues, and those are called as known issues, right? If you ever download a certain application that you're going to say, you can see this known issues, and it might be mentioned in the release notes as well. I mean, I haven't seen such issue from Telegram. I don't remember the last time I saw, but whenever you download a new Telegram, you get a release note, what kind of new issues were added, not the issues, but new features or functionalities were added. And then under that, they might actually mention any known issues as well, if there's a known issue. So whenever the software is being delivered to, let's say, to accounting department from the IT department, they might actually mention that, what, there are some issues there. Let's go through them. Let's look at them. And if you accept them, then we're going to release. And they might actually go like, oh, you know what, we can live with that. And the application gets deployed to the production, and that's called as a bug release. Bug leakage is when you don't know that there's a defect, and it just ends up in the production, and then end users find the defect, and that's something that you try to avoid, and that's called as a production issue, right? All right, so and that brings us to the production issue. So what happens whenever the bug is found in the production environment, right? So it is sort of if you look at this picture, this is a workflow of events, or a sequence of events that actually happens. So users find the bug, and that gets reported. And then it comes to the testing team. Certainly, they have to communicate to the testing team saying, oh, did you test? Or what happened? So why did you miss? So, and the first thing that you as a tester will be doing is going through your test cases and then looking for a test case that should have covered the scenario. And maybe you missed. Most likely, if there was a bug, then you missed it. You don't have that test case. So you're going to write that test just in case for the future. Now you need to cover that, right? So you're going to create that test, and you will take care of that part, and developers will take care of fixing the defect, and that will again come back and then go through the same workflow. Testing team will test, goes to the UAT acceptance, user acceptance team, and then they will actually confirm that bug is fixed, and then it gets deployed to the production. Certainly, very I would say unpleasant situation in testers' lives. So whenever there's a production issue, and then your QA lead is just forwarding you that email from the user saying, hey, Jane, can you please take a look at this? Something, happened in production, and here's a screenshot of the issue. And can you please check if we have a test case to cover this, or maybe if we reported the defect in the past related to this. So, but it happens. It happens. So, and because exhaustive testing impossible, you cannot test all the combinations within the project timeline. And therefore you you try to do as much as you can. You try to cover as much as you can during this particular testing period. But of course, it's not something that happens every day. And let's look at this slide as well, the root causes, right? So what are the some of the potential root causes of the defects, right? Where the defects actually come from. So it's not always the code issue. It's not always developer making mistakes, right? So we shouldn't be blaming developers. Don't expect that always developers are the ones to blame. It could be just a deployment issue as well. What does it mean, deployment issue? So you see, application consists of files. It consists of a bunch of files. And sometimes just one file is missing, and just, it was somewhere, they gave you this instruction to deploy if QA team takes care of the deployments. In some organizations, they do. In some organizations, developers take care of the deployment. And a mistake might actually happen during that deployment process as well. Deployment means installation again, right? It's the process of installing that software in the test environment so that you can test. You're not going to test in the actual environment, right? So where all the users can see, can have access. So you're going to test in test environment. And usually whenever you're creating a defect, and at the, during the life cycle of the defect, that might change. You might think it's a code issue, but then you might change that root cause to oh, it's not a code issue. It looks like it was a deployment issue, right? So, and of course, code issue, developer might make a mistake. That's a common one. And there could be a design issue as well. What's the design is a phase that happens before coding. That design phase is taken care of usually an experienced developer, an architect, as we name them, and also senior engineer who's subject matter expert with years of experience, who knows all the, not just one application, but they know all the applications in the organization, all the integrations. As I said, applications don't work in isolation, they work in integration with other systems. So, and that's where the design issue might happen. So that, technical lead or the engineer made a mistake when they were actually putting together this whole design thing with the prototypes and then instructions for the developer. And that led to a certain defect. That might be another cause as well. And of course, it could just be simply a documentation issue. Right. So as I said, documents are also created by human beings and like business analysts, and documentations also can get outdated. And there, by the end of the project, there could be several versions of the document, and you might be actually testing based on older version of the document, and they might simply have to update the document, and you have to update your test cases. So it could be the root cause might be documentation. Tomorrow we're going to talk about SQL,